buenos días, damas y caballeros. Sean todos bienvenidos a este quinto Congreso Internacional de Medio Ambiente del Instituto Politécnico Nacional, Nuestro Planeta, Nuestro Futuro. Comunidad Politécnica, sean todos bienvenidos a este honorable congreso en la hermosa ciudad de Veracruz. Bueno, corrijo, en boca del río Veracruz. Voy a tener el honor de presentar al Presidium. En representación del licenciado Juan Manuel Unanue Abascal, presidente municipal de Boca del Río Veracruz, nos acompaña esta mañana la arquitecta Susana Tiburcio Galicia, síndica única del H Ayuntamiento de Boca del Río Veracruz. También se encuentra con nosotros con la honrosa representación de la doctora Aide Minerva Torres Huerta, directora de investigación del Instituto Politécnico Nacional. Tenemos al doctor Pedro Francisco Rodríguez Espinosa, director del Centro Interdisciplinario de Estudios en Medio Ambiente y Desarrollo del Instituto Politécnico Nacional. Agradecemos la presencia del maestro Juan Dionisio Cruz Guerrero, rector de la Universidad Tecnológica de Altamira, Tamaulipas. Se encuentra también con nosotros nuestra querida amiga, la doctora Diana Cecilia Escobedo Urías, coordinadora de la Red de Medio Ambiente del Instituto Politécnico Nacional. Y nos acompaña también esta mañana el doctor Jonathan Mutuswami Ponia, coordinador académico del Quinto Congreso CIIEMAD. Es para mí un honor volver a encontrarme con todos ustedes y un placer dirigirme a esta audiencia, y vamos a dar inicio con las palabras de bienvenida de parte de la doctora Diana Cecilia Escobedo Urías, coordinadora de la Red de Medio Ambiente del IPN. Adelante, Diana.
Muchas gracias. Híjole, qué gusto. Yo traigo mi speech aquí, ¿no? Ahora con eso de la tecnología. Arquitecta Susana, qué gusto tener a la autoridad de Boca del Río Veracruz, la representación del licenciado Unanue en su persona. Muchísimas gracias por aceptar estar con nosotros esta mañana. Sí, el Instituto Politécnico Nacional pone su sede hoy en Boca del Río Veracruz, en este recinto, y agradece la presencia de la autoridad. Muchas gracias. Queridísimo amigo, doctor Pedro Rodríguez Espinosa, nuestro muy querido Pedro Francisco Rodríguez Espinosa, director del Centro Interdisciplinario de Estudios en Medio Ambiente y Desarrollo, con la honrosa representación de nuestra directora de investigación, la doctora Aide Minerva Torres Huerta, maestro hermanito del Politécnico, Juan Dionisio Cruz, rector de la Universidad Tecnológica de Altamira. Muchísimas gracias por su interés, por su participación, su presencia. Nuestro querido amigo y compañero de muchas batallas, el doctor Jonathan Mutuswami Ponia, ¿no? Coordinador académico y de muchas cosas de este quinto Congreso CIIEMAD. Queridos colegas, invitados especiales, de los que tengo el gusto de ver esta mañana, estudiantes, público que nos acompaña a través de la red, muchísimas gracias por estar en esta ceremonia de apertura. Me siento muy honrada de estar aquí, dando inicio a nuestro quinto Congreso Internacional de Medio Ambiente del Instituto Politécnico Nacional, y se nos hizo hacerlo en Boca del Río Veracruz. ¿Sí? Muchísimas gracias a todos por venir. El tema de este año refleja, nuestro planeta, nuestro futuro, refleja la enorme preocupación de los investigadores ambientales, misma que es compartida con los colegas de diversas instituciones educativas y de investigación que han querido sumarse en este esfuerzo por divulgar el producto de nuestro trabajo. Esa preocupación se convierte hoy en acción, que tiene la intención de provocar cambio, revolución, impulso. ¿Sí? El planeta es nuestro, es nuestra casa, nuestro sustento, nuestro origen, es nuestro. No de unos cuantos a los que históricamente les hemos dejado su manejo, su uso, y muchas veces un uso equivocado por falta de información. Y sí, la información, queridos colegas, queridos estudiantes, la información compromete, porque no da lugar a la excusa de la ignorancia, que cuando es genuina, tiene el poder de justificar los errores y las omisiones. El planeta es nuestro, queridos colegas, estudiantes, queridos amigos. Trabajemos en su cuidado y defensa con nuestra mejor arma que tenemos, la ciencia. Somos generadores de conocimiento, ese que produce transformaciones, ese que produce progreso. Es en la ciencia y en la tecnología donde están las soluciones a muchos de los problemas que nos aquejan como sociedad. En ellas, la ciencia y la tecnología, está la esperanza del futuro, de nuestro futuro, el futuro de todos. Trabajemos con energía, con entusiasmo, para generar ese conocimiento que requieren los que tienen el trabajo de aplicar el conocimiento que generamos. Que no nos dé miedo participar. Recuerden que la ciencia no es política, la ciencia es ciencia, la ciencia es transformación. Los tomadores de decisión requieren de nuestro trabajo, hagamos la parte que nos corresponde con calidad, con energía. Desde el IPN y desde la red de Medio Ambiente, con sus más de 160 investigadores ambientales en 25 unidades académicas y con 15 años de trabajo conjuntos, les hacemos la investigación de trabajar juntos para seguir generando conocimiento. Le extendemos la mano cargada de la calidez que nos caracteriza. Ponemos a disposición nuestras capacidades, nuestra infraestructura, nuestra ciencia, nuestra tecnología para servir juntos a México. El planeta es nuestro y hoy más que nunca requiere que trabajemos juntos, academia, sociedad, gobierno, para que esta nuestra casa tenga un mañana. No podemos dejarlo para otro día, no podemos dejarlo en otras manos. Señores, señoras, estudiantes, el planeta es nuestro porque es nuestro futuro. Bienvenidos todos.
Para dar continuidad esta mañana a este quinto Congreso Internacional de Medio Ambiente, cedemos el uso de la voz con un mensaje a la arquitecta Susana Tiburcio Galicia, síndica única del H Ayuntamiento de Boca del Río. Adelante, arquitecta.
Muy buenos días. Es un honor para mí, en representación del alcalde, el licenciado Juan Manuel Unanue Abascal, darles la más cordial bienvenida a la quinta edición del Congreso Internacional del Medio Ambiente aquí en Boca del Río. Desde esta ciudad costera nos complace recibir a expertos y líderes de todo el mundo, quienes se han reunido para abordar los desafíos cruciales que enfrentamos en relación con nuestro medio ambiente y la sostenibilidad de nuestro planeta. Saludo a los honorables personalidades de nuestro presidio, al doctor Pedro Francisco Rodríguez Espinosa, director del Centro Interdisciplinario de Estudios en Medio Ambiente y Desarrollo del Instituto Politécnico Nacional, y a quien es un honor conocer, porque sé que vamos a trabajar juntos y vamos a estar preocupados por nuestro medio ambiente. A la doctora Diana Cecilia Escobedo, Urias también, mucho gusto de conocerla, al maestro Juan Dionisio Cruz Guerrero y al doctor Jonathan Mutuswami Ponia, un gusto. Este tipo de reuniones son vitales para el futuro de nuestro mundo. La preocupante contaminación ambiental y las políticas internacionales necesarias para combatirla estarán en el centro de las discusiones. Reconocemos que la protección de nuestro entorno no conoce fronteras y que a través de la cooperación internacional podemos lograr un impacto significativo en la salud de nuestro planeta. El desarrollo sostenible es una meta que todos debemos perseguir. Debemos encontrar formas de equilibrar el crecimiento económico con la conservación de nuestros recursos naturales. Este Congreso nos brinda una oportunidad invaluable para intercambiar ideas y mejores prácticas y así avanzar en la implementación de políticas y proyectos que promuevan el desarrollo sostenible en nuestra región y más allá. El cambio climático es una realidad innegable que amenaza a nuestra sociedad y a nuestro entorno. Es fundamental que nos unamos en la búsqueda de soluciones basadas en la ciencia y en la innovación. El desarrollo de energías limpias y renovables es una de las claves para mitigar los efectos del cambio climático y garantizar un futuro sostenible para las generaciones venideras. Sin embargo, también debemos ser conscientes de las amenazas que enfrenta la humanidad en su conjunto. La degradación ambiental, la pérdida de biodiversidad y los desastres naturales son solo algunos de los desafíos que debemos abordar de manera urgente y colectiva. Solo a través de la colaboración global podremos superar estos desafíos y preservar un mundo habitable para todos. Este Congreso representa una oportunidad única para inspirarnos mutuamente, compartir conocimientos y establecer alianzas sólidas en beneficio de nuestro medio ambiente. Boca del Río se enorgullece de ser anfitrión de este importante evento y estamos comprometidos a seguir trabajando en la protección de nuestro entorno y en la promoción de un desarrollo sostenible. Espero que todos ustedes disfruten de unos días de diálogo fructífero, aprendizaje y colaboración. Juntos podemos marcar la diferencia y construir un futuro más verde y próspero para todos. Bienvenidos, muchas gracias.
Muchas gracias por sus palabras, arquitecta Tiburcio Galicia. Enseguida tenemos aquí una sorpresa. El doctor Jonathan Muthuswamy Ponia tendrá para nosotros un obsequio de los participantes extranjeros. Adelante, Jonathan.
Buenos días a todos. Bienvenidos. Welcome to all the international participants, especially from US as well as from India as well as from Kuwait. We welcome you on behalf of all the organizers. Now, this is a surprise which we are going to give, and es una sorpresa, lo voy a traducir un poquito. Es una sorpresa para felicitar a los gentes que están en el presidio. Entonces, a los invitados, si van a traer unos que ustedes pueden recibir. La primera que quiero invitar es Dr. Muthu Shankar. Can you come on stage, please? Yuval Garland, arquitecta Susana Tribusi. Gracias. La siguiente le voy a invitar la doctora Ana Judith que puede darle honor por maestro Juan. Muchas gracias. Muchas gracias. La siguiente voy a invitar Dr. Chidambaram to honor your friend Dr. Pedro Francisco. Gracias. La siguiente lo voy a invitar Dr. Tangabel to honor Doctora Diana. Muchas gracias. Muchas gracias a todos quienes están en la presidium. Thank you for all the invitees to bring this all over from India to here. Es una tradición, un pequeño tradición que dar honor por quien está en la presidium. La doctora Patti ya se conocen mucho de este aspecto. Muchas gracias doctora Diana. Gracias.
Thank you very much from Jonathan and the distinguished investigator from India. Para continuar con esta inauguración de esta mañana, tenemos el mensaje y declaratoria de apertura por parte del doctor Pedro Francisco Rodríguez Espinosa, director del CIIEMAD. Adelante, Pedro.
Muchas gracias. Honorable Presidium, bienvenidos a esto que es el Festival de las Ciencias Ambientales compartidas, orientadas a la resolución de problemas nacionales, donde tenemos la oportunidad de abrir a una crítica reconstructiva, recreativa y científica nuestros trabajos de tesis y publicaciones, donde hoy más que nunca estamos publicando en la frontera de la ciencia, empujando y haciendo hacia más arriba la frontera del conocimiento. Es una nueva era de descubrimientos, no solo de datos récord, por favor, pongan atención, no solamente ya estamos publicando nuevos datos que no existían, hoy nos enfrentamos, arquitecta, a nuevos procesos que no teníamos antes, no los habíamos visto. No se desanimen si son rechazados en sus publicaciones, muy probablemente ni los editores ni los revisores están revisando y están actualizados. No se tranquis. Vamos hacia una nueva era de publicaciones basadas en nuevos procesos que ni siquiera hemos descubierto. Síndrome del pionero. Bienvenidos. Hoy es un día importante donde tenemos que abrir lo que estamos haciendo para que mejor se pueda hacer. La doctora Aide, directora de nuestra parte de investigación de todo el Poli, hizo el honor de tener yo su representación, y su mensaje es de internacionalización. Hoy más que nunca el Politécnico está en la posibilidad de proyectar lo que hacemos y lo más importante, lo que podemos hacer en colaboración, Sharman, lo que podemos hacer con los profesores e investigadores y estudiantes de otros países. Se van estudiantes y profesores de nuestro país a otros lugares de investigación y vamos a recibir a otros profesores y estudiantes. No me quiero extender y quiero decir la inauguración oficial. Se pueden levantar todos y nos vamos a echar un vuelo, ¿eh? Aquí, Boca del Río no va a ser poli hasta que tengamos un vuelo. ¿Listos? Bueno, siendo las 10:09 del día 15 de noviembre, declaro solemnemente los trabajos inaugurados de este Congreso CIIEMAD 2023. ¿Listos? Bueno, aplaudan. Un vuelo, muchachos. ¿Listos? 1, 2, 3. Como nos salió tan bonito, nos vamos a echar otro. ¿Listos? 1, 2, 3. ¡Más fuerte! Maestra, a lo que sigue.
Sí. Les voy a rogar que no abandonen la sala y vamos a despedir con un enorme aplauso a nuestro presidium para dar paso a la conferencia magistral. Muchas gracias a todos. Ya se van muy cobijados por la India. Hermoso obsequio, Jonathan. Vamos a dar paso a la conferencia magistral, hablando de internacionalización. Tenemos a ver, se van a tomar una foto primero, adelante. Ok. Hablando de internacionalización, esta conferencia magistral es de un invitado especial de la India. Voy a tener el gusto de presentarle. A ver si lo pronuncio bien. Esta conferencia magistral será impartida por el doctor Sabarathinam, Chidambaram, Kuwait. El título de la misma es Acceleration of Stress-Strain Relationships Between Climate Change and Groundwater in the Arid Region Aquifer. Estará coordinada por el doctor Pedro Francisco Rodríguez Espinosa. Me voy a permitir leer un currículum del doctor Chidambaram. El doctor Chidambaram Sabarathinam es un investigador del Centro de Investigación de Agua del Instituto Kuwait de Investigación Científica. Es geólogo. Al terminar sus estudios de maestría, se incorporó a la Universidad de Annamalai como profesor en 1998. Posteriormente, obtuvo el doctorado en hidrogeoquímica de aguas subterráneas por la Universidad de Annamalai. Fue profesor y jefe del Departamento de Ciencias de la Tierra de la Universidad de Annamalai desde 2015 hasta 2017. Tiene una enorme experiencia en desarrolló experiencia en modelado hidrogeoquímico, geoquímica isotópica, gases nobles en aguas subterráneas, aplicaciones estadísticas y sistemas de información geográfica. También ha desarrollado experiencia en software. Vienen aquí varios nombres de software y programación. Ha participado en investigación, ha llevado a cabo 20 proyectos de investigación y ha dirigido a 17 estudiantes de doctorado y 18 candidatos de maestría. Ha publicado más de 250 artículos en revistas especializadas, 9 libros, 58 actas de congresos, 12 capítulos de libros. Ha desarrollado los programas What Class, Water Classification of Stability y Chidambaram, Chemical Interpretation of Laws of Dissolved Aqueous Media, para comprender las propiedades termodinámicas del agua y clasificarla con distintos fines. Tiene varios premios y distinciones. Ha sido galardonado con el premio al mejor artículo 2013 por la revista Applied Water Science Journal. Fue galardonado con una medalla a la mejor contribución en el campo de la hidrogeología y geoquímica ambiental durante 2016, otorgado por la Sociedad India de Geoquímicos Aplicados y de la Barap. Recibió el premio Dr. Héctor Mayagoitia Domínguez, Lecture Series for Contribution en el campo de la hidrogeología e hidrogeoquímica del Instituto Politécnico Nacional, México. La misión fue del 10 al 15 de septiembre de 2018. Actuó como experto en algunos programas de capacitación y talleres del IAE y está incluido en la lista del 2% de los mejores científicos del mundo para el año 2022, publicado por la Universidad de Stanford a través de la plataforma El Ciber. Es para mí un honor presentar esta mañana al doctor Sabarathinam Chidambaram. Muchas gracias. Adelante.
Gracias. Thank you very much. So good morning, everybody, and it was a great honor to be here on this occasion. I hope I can stand here. Okay. I think I'm visible. More than the podium, I think I can stand here, or if you want me to go there, I'll be there. Okay. So, good morning, everybody, and thank you for the opportunity to be here on this occasion of the 5th International Congress. And it is a pleasure for me for the first talk, and it is really a honor. And here, first I just wanted to give you a glimpse of the water, which is a very scarce commodity, and where all our sustainable developmental goals of United Nations are focusing on life, water, and marine organisms, and at last we stand at one health. So, considering the importance of water, I thought it would be more appropriate to shed some of the important developments which are happening with regard to the climate change. So, especially with respect to arid regions, I represent Kuwait, where the groundwater resources, fresh groundwater resources are very scarce, and we mostly depend upon desalination. And desalination is the main source of fresh water in Kuwait. But we have a small quantity of fresh water in north of Kuwait, and we conserve it and we use it cautiously so that it can be sustaining in future. So considering this importance, I have just given I'll just give you a glimpse of what is going on, and to orient with respect to climate change. So here my presentation will be something like this. It will be on, it will be, I'll give you some introduction about the climate change and groundwater vulnerability, stress in the aquifers, and then something on climate change or the microclimatic changes which is happening in the region, how it affects the water. I'll give you some case studies in arid regions and some one study in Korea, so that you can compare the region with more groundwater and less groundwater. And then how we are going about in future and what will be the way forward. So considering this, whenever you go for research, you do a literature survey, and in that literature survey you search for the topics which you wanted. And this one, which is just on the Scopus database, when you search on the groundwater, aquifer, vulnerability, stress, you type these keywords and search on the Scopus database, you will get nearly about 4,000 to 5,000 articles. So now I wanted to know the linkages between all these keywords which are used, and which is the most important keyword which is being used frequently, and what are all linked together, and how that topic has evolved with respect to years. So for that, you can see here, this is the color which is represented on the, probably it is not pointing. So this color represents the older publications or the older keywords, and these are all the new keywords. The problem here representing this kind of a picture is sometimes you may have emerging keywords which are in the publications for 2 or 3 occurrences might be there, which may not be represented in these kind of pictures. So we will have a minimum occurrence of 7 or 10. So only those which are repeated more than 7 times or 10 times will be represented in these kind of pictures. So I have taken a database which consists of about 4,500 articles, and this has 65 keywords. It's all represented here. And then 25 minimum occurrences should be there. Only those keywords are considered to draw this diagram. Okay? So here, these are the linkages which you can see how the groundwater is linked to different fields like vulnerability, GIS, and you can see the older keywords which are in dark colors, younger keywords which are emerging on light colors, and how groundwater is linked to climate. So this kind of analysis is done, which shows that most recently all the groundwater vulnerability assessment are linked towards machine learning and then leading to deep learning techniques. Okay, so that is more now on climate change related studies. I'll show you slowly. And this is the common climatic classification which is given. And this is a Köppen classification wherein you can see that this is an animation which was prepared in the article, which shows that how the temperature or the climate will be changing in subsequent years. You can see the years on the top right, you can see the years are being changing, and how the climate will be moving in the coming recent years, how it will be changing from the equator to north or to the south, and how the tropical regions will be persisting. And this is a model, and in the model which they have used is basically precipitation and temperature. So these are the 2 basic parameters which were considered to develop this model to see how the climate change is impacting. So whenever we say something which is related to climate, it is always related to these 2 parameters, precipitation, temperature. So most of our climate change models which we talk about are basically from the data which we obtained by remote sensing satellites. And satellites, if you can see here, you obtain some data from the surface, it is captured, and then it's assessed by the softwares, and then we try to project in the region which we don't have a data. For example, on a real-time observation, suppose in the desert regions, you may have only 4 locations or 5 real-time temperature and precipitation monitoring locations. But when you do it in remote sensing, it captures with respect to different points, and then it interpolates the other points. Okay? So to compare interpolated data with a real-time data, it is slightly difficult. We don't have a calibration mechanism in such a way that your number of real-time data points are lesser than your data points which you take it from the remote sensing data set. So most of our climate change models are dependent upon the data points or the surfacial expressions of the earth. For example, your land surface temperatures or your drainage features. I'll be showing you what are all the other factors which we will be concentrating on. So just to say that you have data which is being captured from the surface, and then it is related to the other human related process like agricultural, land use change, etc. Okay? So this for the MENA region, Middle East, North Africa region, through Cordex. This is the climate change downscaling mechanism experiment we have. And this is the region for the MENA, Middle East and North African region. And it has to be downscaled with respect to the temperature and the precipitation. And you know, the precipitation in arid regions is very less, somewhere around 100 millimeters per year. Sometimes even during precipitation, it is evaporated. So the amount of water which we receive for recharge is very, very low. So considering that the precipitation the data which we get from the remote sensing imageries are less validated. It's not validated completely with the ground data, okay? And then temperatures. So temperature, obviously we get the atmospheric temperatures or the land surface temperatures. So then we try to downscale, project it for different scenarios and see how the climate is going to change. And with this data only, we are going to see what effect it gives on groundwater, okay? So I have told you there are certain uncertainties with this kind of data. So in this condition, we will have to go real-time data set also, okay? So that being the point, these are the different stages how you develop a map for groundwater hydrology using the climate change experiment. So wherein these are the stages, global climate change modeling, first you get down the data and then regional data, then go for hydrological modeling, then vulnerability assessment, and then go to integrated mapping. So these are the different steps through which you get a final vulnerability hydrogeological map. But for example, this is Kuwait. We have observation stations only in these locations. So there are places where you don't have observation stations. So for example, you don't have an observation station here, you don't have an observation station here or on the top. So this being the case, you will not have enough data to validate the entire country. You get it? So when you go for a climate change study, you need to have enough amount of data to validate your entire data set. Whether you're going to compare it to agriculture or water or any field, you need to have enough amount of data to validate the data set. But still, since we don't have that kind of data, we rely on the available data sets like this, okay? So that is why there are good comparisons with respect to temperatures, but not with respect to precipitation. When you see the projection of climate GCM models, the projection of GCM models for next 100 years, 200 years, if you can see, there is a good comparison for temperature, but there is no good comparison for rainfall, okay? So there is an ambiguity which always says that the models are not 100% true, or not 100% true. Okay, so now coming to the groundwater resources. I've just given you a brief earlier to state that there are data requirements still there to study climate change related topics, may it be to any field, may it be to groundwater or agriculture or any kind of a field. So with that background, we now come to the groundwater resources. So the main drivers with respect to climate, which I was mentioning you, is precipitation and temperature. So apart from that, you have anthropogenic drivers, man-made, so which are land use pattern changes which are happening recently, and related to that partially sea level rise by human being, and then population, changes in building density, and then vegetation, so variation in vegetation patterns, which affects the water level land surface temperature, runoff, recharge, water quantity, and also the flow dynamics and the geochemistry. So these are all with respect to the flow I have just represented here. I'll be going one by one so that it will be easy for you to capture the concept. And here, to study any data set, we have to see the dimension of the data set with respect to water. So here, with respect to the stress in the aquifer, you can see that I have divided into different dimensions. There are different types of data to be considered when you study with respect to climate change. So those data on the top are static parameters, are those parameters which do not change with time. Okay? So for example, lithology of a region, or it may be a soil of a region, topography, geological structures, drainage, aquifer properties, aquifer types, whether the study area is located in the coastal region or in the inland region. So these are all parameters which play a major role in governing the water properties. Okay? And these properties do not change with time. So that is why we call these properties as static parameters. Okay? Now there are other parameters which change with time. So these parameters, if you can see, recharge. Recharge varies with respect to the amount of precipitation which is received. And precipitation is not a standard property. It changes with time. And depending upon precipitation, the recharge of aquifer varies and the water level changes. So then, because of this parameter is not a static parameter, it is a dynamic parameter, or I call it as a temporal parameter which changes with time. And then depth to the water level, and depth to water level plays a very important role, not only for that of your recharge properties of a region, to the temperature of a region. So the shallow the water level, the temperature is very less, means it's slightly humid on the top. So the depth of the water level, or in the other way I say this is unsaturated zone thickness. So the thickness of unsaturated zone plays an important role in climate. And then rainfall, there may be extreme events, and rivers may become dry, and then atmospheric temperature variations, which also governs the land surface temperature and the groundwater. Population growth. Population of a region is generally growing for any country, but the main property which is to be studied is the density of the population. So for example, the coastal region, you will have more people or more population growing in a region, but the density of the population, or the thickness or the amount of people living within a particular area, that is very important because they extract more amount of water than the normal growth in population. So the density of population, then land use pattern changes where your built up land is more, you consume more agricultural land, and you occupy the urban space. So that occupies, and then land surface temperature, which creates urban heat island, but in sandy regions, arid regions, it is urban cool island. You have another effect called as an urban cool island, where your sandy regions have more amount of radiation than that of your cities. So nighttime it cools. So that is a reverse phenomenon which is observed only in desert arid regions. And then this temperature variation or the at last intrusion or aquifer along the coast will this into static parameters and the dynamic parameters. We study the aquifer with two different type of parameters and the dynamic parameters. We study the aquifer with two different type of parameters, may it be a dynamic parameter or it may be a static parameter. Now, for example, this is a 100-year database of, this is for here, there is a variation noted after a particular period. You can see, after a particular period, there had been a definite change in the rainfall patterns. So this is not a phenomenon which is only observed in Mexico. It is also observed in many other countries. That means there is a change happening with respect to rainfall events. Okay? Similar to that, there is temperature events. And this is again for Mexico for 100 years of temperature range. And you can see that extreme temperature, you can see the increase in annual temperature. This is the pink diagram, is the annual increase in temperature of Mexico. So wherein you can see that recent years, there is an average maximum increase in temperature ranges. Okay? So when you compare this to that of the other GCC region, you can see here, mostly there is a variation in temperature also in most of the GCC countries, and you can see that there is an increase in temperature. But in certain countries, you can see a static nature. That is after the climate change Rio summit, they started taking action to reduce the CO2 level, emission of CO2 level in the atmosphere, and that has brought the temperature level to be static. That's what we infer. But there are static natures observed in GCC region. Okay. Yes, so the basic two parameters I have told you, temperature, precipitation, and the geological structures. I'm just telling you the variables, like the static variable and the dynamic variable. I'm giving the examples. So this is a geological structure. You can see here, this is with respect to unconformities, the flow of water, which you can govern with the help of a bedding plane or any definite structure. And you can consider a same scenario with a structure or without a structure. For example, you can see here, the one at the center here, I can consider this structure without any boundary, but definitely on a natural phenomenon, you may have a boundary which I might have missed. So if there was a fault in the region, then the boundary, natural boundary is being fixed. So definitely the structures of a region play a very important role in the groundwater resource estimation and getting the background value of the entire basin. Okay? And this is with respect to groundwater flow. So you can see here the arrows indicate the flow of water. So you can see there is a change in the direction of the flow of water. On the first scenario, if you can see here, there is a flow from this elevated region to the basin here. But on the last scenario, you can see the same flow is now being diverted to different regions because one region is going very deep, the other region is relatively deep, you have a divide in between. So because of more extraction in regions, the groundwater flow direction gets changed. Okay? And again, this is with respect to population increase. So obviously there is an increase in population, especially along the coastal regions. So the coastal regions show higher amount of population, but that is more vulnerable than the inland regions. Because coastal, we extract more groundwater, and the susceptibility of the aquifer to the coastal sea water getting inside, which is more serious than the inland aquifer. Okay? And next, again to that, apart from increase in population, density of population is very important. So more number of people crowded at one place will consume more amount of energy and water than people living scatteredly in a region. So density of population also plays a major role than that of normal increase in population. Okay? Yes, and this is the urban heat island effect, which is also now related to the groundwater studies, depending upon the depth of the water level or the thickness of the Vado zone. And now there is emission of this nitrate. Nitrate is being reduced to nitrous oxide, and that is a greenhouse gas which is being emitted near the surfaces, and it forms the greenhouse layer, which is also responsible for the climate change variation. So groundwater is nowadays related to the urban heat island also. So these are some of the case studies which is represented here with respect to climate, which city is reported and what is the reference. So I have just given you some glimpse of the urban heat island effect throughout the world, and this is a common term which is being used nowadays, so I have no need to explain what urban heat island effect is. And this is for Mexico City. So wherein you can see here, this one is in 1997 and this one is in 2009. So you can see that red hotspots which have increased spatially nowadays. So that is with respect to temperature, and the other one is urban cool island effect, which I told you, it is more prominent in the desert regions where the sand of the desert is more emissive than the covered land surface. So urban land which is covered, or the city which is covered, gives a lesser emissivity than that of the urban, than that of the sand. So In arid regions, you have urban cool island effect than that of heat island. Yes, this is with respect to temperature and groundwater. You can see land surface temperature with respect to groundwater temperatures. It has a linear relationship. You both have a linear relationship. So that means when there is an increase in land surface temperature, it is easily correlated to the groundwater temperatures. But this is with respect to shallow groundwaters. You cannot relate this to deeper groundwaters. Okay? And you can see with respect to depth. So as I have told you, on the shallow groundwaters, the temperature is different, and the deeper groundwaters, it is different. And this increase in temperature is because of the geothermal gradients. When there is an increase in temperature with respect to depth, so that increases this temperature. And here, this is with respect to the last one, is with respect to surface atmospheric temperature compared to that of the groundwater temperature. So you can see both are similar to each other. This is the annual atmospheric temperature to that of the groundwater temperatures. So that has also a correlation with the climate. Okay, so now what was done was this variation in temperature was used as a geothermal gradients to develop energy. So this is for a study which was done, which was in environmental research letters, wherein the difference in this geothermal temperatures on the surface and to the deep was used to generate power for a particular city. So that experiment was done in Germany, and they have some interesting findings. I have not given it here. But this, just to tell you that much amount of temperature is being used to develop this even power for a city. Yes, and I was talking to you about the position of the aquifer, coastal or inland aquifers. So the coastal aquifers are more vulnerable. You can see a normal rise in the seawater can submerge most of the eastern coast of the US, so that everything is submerged. You have only a small piece left over because of an increase of sea level rise. This is a report from NOAA. Yes, now I come to small case studies. I'll just try to push it out fast. And this, as I have told you, whenever I start doing some research, I do with literature. And literature, I try to put it up in a VOS diagram. And this is the linkage of the commonly used keywords and how, what is a gap now. You can see here, this is with respect to groundwater and what are all the recent keywords used and how they are linked to each other. That we can get it from the VOS linkage diagrams, okay? So with this, then I go to the area where you can see that this is an urban region. As I've told you, it's a case study, it is in arid region. And this arid region, we have lesser number of samples distributed. This is one of the limitations of the study, but we are trying to build upon it. With this limitation, we try to bring out something which is slightly different observation which we got. And you can see here the annual temperature, annual rainfall which I was telling you. On 100 millimeter per year is the average rainfall in Kuwait. And you can see there were periods which had higher amount of rainfall. And we even had the flooding, urban flooding in one particular time period in 2018. We had lot of rain event during that period. And the water got stagnated, it was flowing, and it was really a very interesting sight to see in a desert region like that. And now then we had an idea, why don't we compare 2013 data to that of 2023 data and see if there is a variation with respect to climate on the groundwater resources. So for that, what we did, we tried to get the land use pattern changes. So you know, Kuwait is a fast developing nation, and you have lot of constructions which are occupied in the recent days. You can see the difference between the 2013 and the recent map. Generally, 10 years you will not have much of a vast variation in development of a city, but you can see here there is a vast development. And these green regions represent the what do you call protected agricultural regions. we have a protected agricultural region, so wherein we have growth of plants, and you have the land use change map for 2 different periods, and where it is changed, the colors are given there. And then this is with respect to land surface temperature. You can see that it's quite interesting to see that in 2013, the temperature was higher. The land surface temperature was higher. But in 2023, the land surface temperature range was lesser. So means the recent time period, the land surface temperature became lesser. In the earlier time period, the land surface temperature was higher. So now we try to compare this, whether it might be because of water level rise, or because of the flood event which happened in between, or you know that urban cool island effect, I have told you. Lot of constructions which have taken place have brought down the temperature than that of the sand. Sand temperature was higher and the building temperature was relatively lesser. So the emissivity property. So lot of the regions which were covered with sand was removed and it was now constructed into universities and extension of airport, and lot of other construction activities were there. So that has brought down the temperature. So now this is with respect to the vegetation index and the building index. So where the vegetation is higher and where the building, this side represents the vegetation and this side represents the building. So whether the buildings were higher or vegetation was higher. We try to compare this because vegetation governs the water property, and the vegetation here also includes the roadside plants which are grown for shelter, and you know most of them are salt tolerant crops. I don't get the exact term, might be halophytes or salt tolerant crops are there. And then you have the building index, because for the density of the population, we try to get the building index of that region. So we try to extract both of them and try to compare. And this is the swarm plot. We developed a fishnet placed on the top of the land surface temperature, and try to extract the values of the points. And all the points are distributed here. And generally on an index, it is ranging between 0.1 to -2 plus. So you can see that those which are represented by vegetation are positive, and you have negative vegetation index also. I'll tell you why. Because in 2023, there is a small variation along the coast because of the tidal time period. There was a variation. So this was again reflected in the map. And this is building index. So the variation in building index with respect to time period, you can see there is an increase in building index. And this is with respect to water level. So you can see that the water was deeper in 2013, and in 2023 it was shallow. So that is mainly because of, we attribute that to the flood event which happened in 2018. And that didn't go because we had a concur layer, means a layer which is semi-permeable, or we call it as we refer it as a concur layer locally, means you have a impervious calcic layer which will not permit the water to flow below. It will get stagnated on the top itself, like a perched aquifer kind of. Okay. And with this we try to compare the, yes, you can see the land surface temperature and the water level. So you can see that this is the water level, and the red ones are the land surface temperature. You can see with respect to time periods, there is a decrease in temperature with respect to the surface, and you can see there is an increase in the water level. So the increase in water level and the decrease in land surface temperature showed that these two parameters had an interrelationship, water and the land surface temperature. And similarly, we wanted to know whether brackish water is recharged or originally it is fresh water. So when we try to compare the electrical conductivity of the two different time periods, generally the EC has improved, means it has not become saline. It has not become saline. So it shows that it is a freshwater recharge. So this freshwater recharge, again, we attribute to the event, 2018 flood event. Yes, just to show you that there is a decrease in the electrical conductivity values, you can see that there is a decrease in the value with respect to 2023. And we try to correlate this for two different time periods. You can see here the different parameters which were taken, and the center one is the mode, and the other side we have the correlation values. You have a regression value as a bivariate plot on one side, and you have the frequency of the distribution, and on the other side is the correlation. So you can see that there is a good correlation between EC and the water level, and you can also see that the building index has a good correlation to land surface temperature. Okay. So to sum up that study, we came to a conclusion that there is a decrease in land surface temperature in 2023, and this decrease in temperature is mainly because of the rise in water level, and this increased water level is mainly because of freshwater recharge. And though the image was captured 2023 and 2013, the image was captured on the same day, on same month, but there was a variation with respect to tide. The tidal time period varied. So those vegetation which were exposed along the shore reflected in 2023, which was not represented in 2013. That showed negative vegetation index, which you can remember there were some values which were there on the study. So more building has developed, and a lesser amount of the sand area was there, so the reflectivity was lesser. So obviously the shadow effect also caused lesser amount of land surface temperature. And since the region is more towards the coast, you have the sea breeze also. So apart from water level variation, there was an impact from the other meteoritic parameters which has reduced the land surface temperature. So that was a paper which was submitted to environmental research, but it's still in under review. And this one is to study machine learning with respect to the groundwater contamination or the stress related to the aquifer pollution which is happening. But this doesn't have a climatic factor involved. It only tries to learn the process which is with respect to one particular ion. Generally, we take nitrate. Nitrate is the common contaminant which is present in the region, which reflects the anthropogenic pollution too. Because chloride is a conservative ion, it doesn't reflect much the anthropogenic pollution. So we take the nitrate as a parameter for studying. So this is one study in Korea which was done with one of my associates there. And we try to find out different machine learning techniques and to see which is the probabilistic, accurate, or means more suitable technique which can be adopted. So different techniques were used and we try to bring out. Again, there you can see, probably this is not clear, these are the 8 parameters which were used to study the vulnerability or to identify the stress in the aquifer. But the issue was none of these parameters were related to climate. Everything was related to all the drastic parameters along with land use change. So the only parameter extra added was the land use change. So apart from that, no climatic factor was added to study the aquifer. And this was again the same method. We tried to slightly modify the study with respect to different fuzzy logic techniques so that we try to incorporate one more climatic factor, this is precipitation. So we try to incorporate that and develop this kind of fuzzy logic techniques and to find which method will be more suitable to study the contamination. Okay, I'm not going into details of it. I just wanted to say we have tried to evolve including some of the climatic factors in addressing the stress in the aquifers with respect to contamination. Okay, so I'll just give you an overview. Generally, the stress in the aquifer we study with respect to vulnerability, and vulnerability is quite commonly wrongly misunderstood, that the contaminated area and probability to be contaminated. So we concentrate more on the probability to be more contaminated as vulnerable than already contaminated area. So the probability of getting contaminated is done by different methods. They're all listed here. And this is taken from a publication, and there it is a very concise and a very nice publication which has compiled all the available groundwater vulnerability assessment models. So that model shows you that article shows you the advantages and disadvantages of all the existing groundwater availability, vulnerability models. Okay? So this is with respect to statistical techniques, and you can also do this study with respect to overlay. You develop your own index, and with this index you try to overlay different layers and see which is vulnerable and which is not vulnerable. So you have another method. The earlier one was the statistical method, and this one is the overlay method. You can have these two combined together also. They are called as hybrid methods. You can combine the statistical method with the overlay method and to have a vulnerability assessment. And yes, so that being the case, you can see even here, in most of the vulnerability assessment models, this climate dynamic phase is still missing. So most of the, if you want to orient your study with respect to climate change and groundwater vulnerability assessment with respect to stress or strain in the aquifer, we still miss the climatic dimension. This the temperature, precipitation, and how it is changing. All the dynamic factors which I was mentioning to you in the first few slides are still missing in the vulnerability assessment models. So yes, so nowadays we need large volume of data to process, and this large volume of data, it is not necessary to generate the data. We can get it from different websites which is already available, may it be World Meteorological Organization, or it may be Food and Agriculture Organization, or any UN body has lot of data which is available already stored on the internet. For example, even your isotope data, for most of the specific countries, even from 1950s, you have isotope data for rainfall, you have isotope data for water, in the river water, groundwater. It's in WISER portal in IAEA. So wherein you can get the isotope data also. So we need to work integrated together. The problem is, for a nation, we develop a database which is not shared to an adjacent nation. So in that case, when you want to solve a problem which has a regional or a very global significance, we need to have data which is distributed throughout the world. You cannot concise your data within your country alone. Then neither your purpose will be solved, nor the neighboring country purpose will be solved. So in that case, we need to have a broad mind to bring out the data and put it on the portal so that everybody can make use of the data to get a global overview of what is happening in the region. Okay? So that is one of the reasons why most of the transboundary aquifer cooperation gets failed. So you have all the agreements, but some of the critical data, you have more than 147 transboundary aquifers throughout the world, major transboundary aquifers. So, but we have all the agreements, but still there is a small hinge which we are not able to overcome, is data sharing. We don't share certain data and we think that is confidential, so then we will not be able to solve either your problem or even my problem. So treaty will be as it is on paper. Okay? So in that case, what we need to do is we need to collect all the available data and we can process the data. And nowadays, I had an earlier lecture 2 days back. We were more on the big data analysis and cloud computing and all. So large volumes of these data have to be done on cloud computing, big data analysis, so that you get an overview of the entire thing. So it's not necessary that research should be generating a data. You can make use of a data which is already available, voluminous data which is already available, and you can validate your data set also. And that being the case, this will be my last slide. And how to proceed forward. So you can see here the main drivers of climate is, it may be a natural driver like precipitation or temperature, and that can be in way related to anthropogenic, or it can be a man-made, or it can be even natural man-made interlinked. But the data sets which we have already, you have a static data set, you have a dynamic data set, and certain superficial expressions which can be captured from the imageries, which I was discussing to you on the NDVA, NDBA, LST, land use, land change. So some of the superficial expressions of a region from the imageries, you can take it out, compare with the meteorological data, see if there is a change in chemistry with respect to time period, and whether geology plays a major role or anthropogenic processes are governing the chemistry of a region, and whether it is related to climate, these two factors, or you can make use of already available data set which is there in the repository and try to bring out a novel finding. And the tools which we generally use, I have listed here. These are all some of the common tools which we generally use to address this problem. It's always better to use a tool integratedly than to use the tool independently. For example, no tool is conclusive, will give you a conclusive inference. For example, it may be a model, it may be an isotope study, or it may be any other study of the nature. No tool is conclusive. But when you use it integratedly, it can give you an idea so that you will have a common identification of the problem. So that will be more conclusive than that of using independent tools. Okay? So that is how I think the climate phase can be addressed with respect to the groundwater issues. And this is more into UN now. So the SDGs are more trying to link all the other SDGs, because earlier it was each SDG has been separately addressed, like 6 was water, and then climate, and then life on earth, marine separate. Now we are trying to put everything together. So all SDGs are going to be interlinked. And at last we land at one health, one entire earth biosphere conservation. So with this few words, I conclude. Thank you very much.
Muchísimas gracias, doctor. Ahora se abre el espacio para comentarios, preguntas y respuestas, que será moderado por el doctor Pedro Francisco. Adelante, Pedro.
Muchas gracias. Se abren las preguntas y respuestas. ¿Usted tiene micrófono?
Thank you, Doctor, for your speech. I think you forgot one item in your data, the communities, the organisms.
Yes.
Because the organisms modified the environment. So
Yes.
it's a point really difficult to measure,
Yes.
but it is necessary.
Obviously, yes, you are right. You are right. The biosphere component, what she was missing, what she was mentioning, is not added in this. Now we try to address the eDNA signatures also in water resources. So probably that will be added in the next presentation. Thank you.
Dr. Chidambaram, congratulations.
Thank you.
It was a very interesting speech where you can ensemble many things I don't have seen something like.
Thank you.
I have a commentary about Mexico.
Yes.
I have worked for many years with data, weather data. There is many problems with quality control. There is a problem with series because there is a lot of problem of errors. We must have many caution with the use of Mexico data because the quality analysis is very low. In the long time, it's maybe no problem, but many things are necessary to review for Mexico, only for Mexico.
I get your point. I get your point. See, actually, the data which is presented here, for example, in Kuwait, there is a data which sometimes in some places the temperature reaches more than 50 degrees also. When you see the maximum minimum temperatures, it will not be 50 degrees. It will be an average value. So it will take an average of the entire country, and in that case, that 50 will be brought down. So that 50 max will not be represented in the data. And to get more authenticity, what we do is, if you can see the site which I have downloaded, it is from UN site. So you cannot question UN agency which has provided the data. So I was thinking that point which you were telling, because generally we don't get the data. As you know, validity of data is also very important for interpreting any process. But still, we'll have to see who is providing the data. So the data which I presented here, I put the reference below. It is from WMO, World Meteorological Organization. So I think
Is there any remote sensing data to measure the stress on groundwater levels?
yes, of course. I think my friend, an expert in remote sensing, he will be adding it in his presentation. Yes, Grace, generally we do. You know that alluvial plain, that was one of the talk of the town those days, where NASA, I think, right? They studied the water level variation with the GRACE data, groundwater level variation of the GRACE data. And that was the breakthrough study those days. And now we have a lot of other techniques emerged. Yeah.
Yes, congratulations again, very nice study and lot of hard work.
Thank you, Doctor.
Appreciate that. So now you think we can grow some plants in Kuwait? What's your prediction? Is your model can help?
In
Kuwait?
yes.
Can in desert or arid region,
Yes.
can we grow plants? Can we create some plants or something so we can feed the cattle?
Yes,
they,
we are
they
doing.
use a lot of beef.
Yes, we are doing.
They do a lot of.
We are doing, but we have
Yes.
not reached the.
Can you get us the direction? Is it possible or not possible, or what's the prediction using your model? Can you relate to the food, for example?
100% I cannot answer your question,
Yeah.
but partially.
I'm just going beyond what you're presenting.
Yes.
I'm saying how you can guide us using this machine learning and this what you presented about the health, because food is also related to health.
Yes.
Because food is a big problem, and to eat meat, you need much more food rather than
More water
vegetarian.
also.
Yeah, but
Virtual water consumes more water, yes.
Because you need livestock needs
Yes.
a lot of water.
Yes.
Compared to vegetarian, they use very less water, but livestock will require more water. So can you guide us something using this model?
Yes, Doctor, partially.
Sorry, I'm
we-
going beyond what you're presenting, but I thought just ask this question.
No, we are now concentrating on fit for purpose use. Basically, we have brackish water and fresh groundwater. So we are trying to categorize the water with respect to what we have. We just need to know what is our potential. So we categorize what is the brackish water content we have in Kuwait, and what are all the purposes these water can be used. So that is generally termed as fit for purpose use. So with that, we try to bring out some salt tolerant crops, generally fodder crops, which can satisfy the growth of this for the cattle. But still, again, this is an energy consumption process when you link it to water food nexus. It's an again energy consumption process, because we need to.
But that region may not have energy problem. They have a lot of fuel.
But still, it's related to water food energy nexus.
I'm just provoking
Yeah.
here. Sorry,
It's a very good,
audience here.
it's a very good-
Because there are young people here. These are real issues.
Yes.
And
yes.
I thought it just provoke.
It's
here
a very
by
good
asking
issue.
this. Sorry if I got
No.
beyond this
It
thing.
was a very good thought.
So thought provoking. Maybe we can add the health issue in the next conference.
Yes.
Food and health.
But it cannot be 100%. We will not be able to achieve
Nothing is
sufficiency.
100%
Yeah.
anyway. So life is
Yeah, that's true. Thank you, Doctor. Thank you for the insight. Yes.
Hi, Doctor. Thank you for your presentation. We are currently working with contamination index, and I wonder why in your models you don't consider this part, the contamination part, in the vulnerability assessment, because I hear when you present the part of the contamination that you don't integrate the climate change or the climate drivers to this process of contamination. And we are currently trying to interpret this part, the climate drivers with the contamination index. I was wondering why you don't consider this part in this model.
Yes. It's a good question. See, actually, this contamination part, I have put it as geochemistry separately. If you can see one of the first third or fourth slide, I remember, wherein I have put some static parameters and dynamic parameters. So in that dynamic parameters, I have added chemistry in that, geochemistry. So in that geochemistry, I have tried to incorporate all the geochemical variables, may it be any contamination of that sort. And you know, the index developed by one person will vary with the index developed by another person. There are a lot of contamination index with respect to a particular metal or etc. And similarly, sometimes when it is related to standards, standard again varies with respect to country. And it depends upon the consumption of water, means amount of water which you consume, and that varies with respect to country. And geographically, you are located in a different country, and in an arid country it is different. So there are a lot of other factors which govern the contamination index. So it's always better to link a contamination with respect to climate than to a standard index. I think you get my point. The amount of rainfall which you receive in a country may dilute a contamination. And the amount of heat which is present in a country may give a different kind of a reaction, which is a photocatalytic kind of a reaction, which can even produce more hazardous material. And nowadays, people are working on this persistent organic carbons, which again, they are going to study with respect to the thermodynamic properties. So it's always better to link with the climate variables and the index than rather to go with the standard available calculations of the indices. So I've just put it in broad terms as index, that chemical variable. But at last I showed you one with respect to nitrate. Two fuzzy logic technique and the machine learning one was related to one particular parameter alone. Yeah. I hope I answered your question.
The last one. Remember that the Dr. Chidambaram is expert in isotopes, stable and not stable isotopes. Okay. Do you want any question? Any?
Yes.
Yes, doctor.
This is just specific for your presentation. You said there are a lot of data out there. You can just use it.
Yes.
For how you are sorting out which is good data or bad data or just
Authenticity.
using? Yes. See, WMO, but
Yes.
do you go beyond WMO in your presentation or?
During COVID, we didn't have enough data for population, rainfall, temperature, etc. We were trying to get it for meteorological parameters and compare that to COVID distribution. So we try to get the data from this NOAA website. So wherein you get temperature data for a specific latitude, longitude, and the meteorological other meteorological parameters, wind speed and everything. But we rely that this data is provided by a reputed organization, and if at all you want to compare with the already published data, of course you can validate the data of the organization. But still, when you don't have a data, for example, in an arid region, you don't have a real-time observation monitoring stations there for a temperature or water level. We don't have stations, people don't stay there, or we don't get data. Sometimes it's being destroyed. Even in our country, if you keep, it should withstand that temperature. So in sandstorms, the solar panel is completely covered. So we don't have, we don't receive the data. So that again was a problem. So in that case, remote sensing comes handy. So we take the data from remote sensing imageries only.
And last is, sorry, yeah.
Yes.
This is how much this PowerPoint you can share with us. This is very proprietary information.
No, this is a general information.
We all will be benefit if you can share with the conference organizers, so we can use even
of
for
course,
better,
doctor.
or we can use even
Yes.
for our classes. Some of the professor
Yes.
or some young students here. I think it's very excellent talk.
Thank
So
you.
they will be very benefit for that
you.
if you accept the request. Thank you.
Thank you.
Gracias.
Gracias. Thank you.
Okay. Thank you very much, doctor. It's amazing that the unconfined and confined multi-dimension models. That's right. Very good. We need to move it about that. Okay. El doctor nos hizo una reflexión sobre la posibilidad de trabajar con la gente del Organismo Internacional de Energía Atómica. Él tiene una muy buena contactación tanto con Bombay, la planta nuclear de Bombay, y en Viena, laboratorio para la parte isotópica. Entonces, nosotros estamos en combinación, en muy fuerte colaboración con ellos, no nada más con él, sino con el doctor Muthu Shankar y el doctor que nos acompaña. Entonces, acérquense, por favor. Las conferencias, estos contactos cambian vidas, podemos modificar la trayectoria que tenemos y hay que impulsar esta parte de la internacionalización. I'm talking about the collaboration in Vienna and Mumbai University, nuclear power plant. Okay, the National Polytechnical Institute, IPN, Third International Conference of Environmental Research Group, IPN, CIIEMAD, 2023, Our Planet, Our Future. This is the certificate to the Sabarathinam Chidambaram has a participate and presentation the invitation lecture on acceleration to the stress, strain relation between climatic change and groundwater in the arid region aquifers, organized by the Environmental Network Research Group, REMA IPN. Signing Diana Cecilia Escobedo Urias, Dr. Jonathan Mutuswani Ponayan. Please. Hold on. I have some presents for you. One carpet.
Thank you.
This is coming from the CIIEMAD.
Okay.
This is magnetic.
Okay.
And your term.
You're giving me a lot.
A lot. Thank you very much for coming. Okay.
Bueno, después de que Santa Claus Francisco llegó aquí con tantos presentes, les quiero dar las gracias y antes de irnos al cafecito, los quiero invitar a la siguiente sesión, nuestro medio ambiente, biodiversidad, recursos y bioremediación, que será en este mismo salón y será coordinado por la doctora Norma Patricia Muñoz Sevilla. Entonces tenemos 15 minutos para ir al cafecito. Por favor, regresen. A ver.
Sí, también hay, el otro anuncio es Salón 2, Salón 3 se va a abrir. Todos quien está presentando por Salón 2 y Salón 3, si puede ir para allá también. Ok, gracias.
Los que van a presentar